minus just AB and then plus B squared. And if you think of this like, oh my god, this is a formula I have to memorize, there's two different formulas, like, so when this is plus, and that's minus, but that's always plus, and when this is minus, but that's plus, and this is always plus, and then it tangles your brain and you panic. And if you remember this from 308, it's like, you probably memorized it, crammed it right before the test, and then you forgot it. Okay? So, don't worry, this is the formula, this is the algebraic way to write it, but I've got a little trick, a little double acronym that will help you just, once you recognize what you have, and you know your A and your B, this is going to get you to plug things right in where they need to go, no stress, no cramming to memorize formulas. Okay? So we're going to come back to that. That's what we're coming to. This is what we're about to do today. Okay? Now, just like the first thing, the first part of the mantra is, where do I start? The end of the mantra is, how do I know I'm done? Right. Because you may have to use more than one kind of factoring. There may or may not be a GCF to begin with, and then you might do four-term or quadratic or binomial factoring, but then you might still have a factor. You might factor, but then one of your factors might still be factorable. Okay? You're not done until all of your factors are linear, meaning there's no more exponents. Sometimes, though, you will have an exponent left, which means you have to check it. Your eyes should go, oh, wait, am I done? No, I still have an exponent. Okay? If it's linear, no exponent, you know that factor's done. But if any of your factors still have an exponent, you got to check it. Maybe you can keep going. Now, it might turn out that it has an exponent and it's done. Like, for example, if you end up, one of your factors is a sum of squares, okay, well, that's not linear, but you can't factor it. Okay, so that means it's prime. Okay? So you know you're done when all your factors are linear, or if they're not linear, you've checked them and made sure they're prime. Because you may be able to keep going. You got to keep going until you can't. Okay? So where do you start? How do you know you're done? Okay? So that's the overview, and now we're going to come back to this. Okay. Okay. Now, again, this is also something written out in the middle class, and I want to make sure we have plenty of time to just practice these binomials. Okay? So again, don't worry about scribbling all this down. This is more about understanding the concept. I'm spending more time than doing the practice, and I do want to leave time for the practice, but more time understanding. Like I said, if you understand what this means, then you'll know if your answer is reasonable. You know if you're going in the right direction. You'll recognize what you have to factor. Okay? The actual factoring isn't difficult. It's the being overwhelmed by, where do I start? How do I know what I'm doing? What does it mean? Is this answer reasonable? Okay? All right. So this is a way to sort of compare. Okay. So I'm going to compare numerical factoring with binomial factors. Okay? So here on the left, I have numerical factors. Try to put it in a way that your mind already knows how to do. You know that, for example, 3 times 4 is 12. Now, I didn't use an equal sign. I used this double arrow because I want to point out, just like with factoring polynomials, yeah, you can break 12 down into factors. Now, there's other factors of 12, like 1 times 12 and 2 times 6, and you can involve negatives and stuff. Okay, and that's not the case with binomial ones. With polynomials, you're just going to get, there's just one answer. Okay, but the same idea. You go from two different factors. Now, these are different factors, 3 and 4, okay? And you can multiply them to get this product. That's a C. Multiply them to get this product, or break it down, make a product down into its factors. Now, when you have different binomial factors, meaning your two binomials are totally different, okay? Then when you FOIL them out, and it's the double arrow because you can go in both directions, you can also factor it back. When you FOIL it out, you get a trinomial or a four-term. If it's not of this nice pattern, you might not be able to combine your middle term. Okay? But you're either going to get a four-term or a trinomial. You're going to get a polynomial. Okay? So, examples here, whether your factors are positive or negative, whether they involve pluses or minuses, that affects your sign patterns. Okay? But you're going to get your simple product, and you can go in the other direction. Negative 16 can break down to negative 2 times 8, just like x squared plus 4x minus 21 breaks down to x minus 3x plus 7. You've got two different factors, and when you multiply them together, you either get a four-term polynomial, FOIL, and in this case, you don't have middle terms that combine because it's no like terms. Okay? But if you have the same pattern where you have x's at the front end and just constants on the back, if you have your first terms match, your first terms are like terms and your last terms are like terms, then you're going to have an O plus an I that you can combine. So FOIL always gives you 4 terms, and when you have matching first terms and matching last terms, then you have a trinomial because you can combine your O plus I. So either way, you multiply 2 different binomials, you're going to get either a 4-term or a trinomial. Okay? And whether they're pluses or minuses affects the sign pattern, just like whether these are plus or minus affects whether the answer is positive or negative. Okay? Now the thing I'm really pointing out here, this is a seed I'm planting, and you might be like, why am I emphasizing this so much? Trust me, this is going to come up as the most common careless mistake 2 units from now. Okay? So I'm planting the seed now. Notice how when you multiply 2 different binomials, you get that 4-term or a trinomial, if you can combine the middle terms. But the whole point is you have a middle term. When you multiply 2 different binomials, you have a middle term. It may not be combinable, but you have a middle term. Nothing cancels out. Okay? Good? Now, if you have same factors, okay? Same factors are a factor times itself. Numerically, 3 times 3, which can be written as 3 squared, equals 9. 9's a perfect square. Now, if you're multiplying 2 negative numbers, negative 4 times negative 4. Remember, when you have to put that in parentheses because it's negative 4 times negative 4. If you don't put parentheses, then it's going to change it to a negative answer. Okay? Negative 4 times negative 4. Anytime a positive times a positive squared is positive, and a negative squared is always positive. Right?
Oh, they're always positive.
Yeah. Well, multiplying 2 negatives, and that's all squaring is multiplying the factors, factor times itself. So whether the factor, the base is positive or negative, when you square it, you get a positive answer. Okay? But the point is, these are the same factors, whether they're positive or negative, they're the same factors, and that results in a perfect square. Now, now that's numerical factoring. With polynomial factoring, same binomial factors, and you can write this as x plus 3 squared. And remember, this is just like the multiplying this out. You can expand it and foil it, but if you just think of this as mental foiling, that's x times itself, x squared, and then your O and your I are the same, because your A and B are the same, because either are the same binomials, so that's just your A times your B doubled, because it's 3x plus 3x. That's 3x times 2, or 3x doubled. And then 3 times 3, your L in FOIL gives you 9. Okay. So, same binomial factors means you have a binomial squared, a binomial times itself, and that results in a perfect square trinomial when you multiply. And if you recognize, if you're given a perfect square trinomial and you recognize, oh, perfect square, my A is x, my B is 3, and 3x doubled is 6x, check, it's a perfect square trinomial. So my A is x, my B is 3, so my factored form is x plus 3 squared. Because my middle term is plus, so that makes that plus. And here's one with minus, okay, times itself. Regardless, remember that negative times negative still makes a positive, 25. But because of that negative O and negative I, that's negative doubled. That's 2x times 5 times negative 5 is negative 10x doubled. Negative 10x plus negative 10x. Okay, so A times B doubled gave us a negative middle term. That was your A times your B doubled. And if you recognize, oh, I can unsquare that to 2x, I can unsquare that to 5, and 2 times 5 is 10, doubled is 20, negative doubled gives me my negative binomial squared. But, planting that seed, regardless, you have a middle term. The middle term does not cancel out. When you have a binomial squared, your middle term is just doubled. Okay? It's negative, positive doubled or negative doubled, but it is there. It does not cancel out. It's a positive plus positive, or it's a negative plus negative. Those don't cancel out. Okay? Now, what we're looking at now are opposite factors. And opposite factors, those are both 3's, but one's positive and one's negative. Now, when you multiply 3 times 3, you get 9, which is a square, a perfect square. But notice I call this negative, I use air quotes, square. Because it's not technically a perfect square, because a negative is never a perfect square. Okay? Because there's no two things, these are not the same number.
Oh, they can't be.
Yeah. The 3 times 3 gives you the square 9, but because one's positive, one's negative, it's negative square. So it's a negative square, in quotes. Okay? So, It is a square number, but it's negative. Okay? And it doesn't matter which one's negative and which one's positive. Okay? Now, what that means is, in polynomial terms, instead of numerical terms, is you've got the same a's and the same b's, but one's plus and one's negative. If you were to FOIL that out, your o and your I are opposites, and when you add opposites, they cancel out. Okay? So you've got x squared for your f on the front end, and 3 squared is 9 on the back end, but because these are mixed signs, it's a minus 9. But your o and your I are opposites, and add them to cancel out, and you end up with the difference of squares. Okay? And that's true, even if you have, doesn't matter, you've got, coefficients here. It doesn't matter whether the minus is first or the plus is first. It doesn't matter. Order of factors doesn't matter. Okay? This is just the front end is 16x squared, and the back end is minus, mixed signs, 49, but the 28x and the negative 28x, the o and the I, canceled out. So when you've got opposite factors, the same number, but one plus, one minus, no middle term. Okay? Okay? So in polynomial terms, if you've got the same factors, exact same factors, that means you have a binomial squared. If you have opposite factors, same numbers, but one's positive, one's negative, then you have conjugates in polynomial terms. Opposite numerical factors, the equivalent in polynomial terms is conjugates. Okay. Make sense? Okay. And again, no middle term. Okay. So binomial squared and perfect square trinomials involve middle terms because your middle term is doubled. Okay. Conjugates, no middle term. Difference of squares, middle term canceled out, opposite signs. Okay. All right. So I will leave this up here for anyone who wants to photograph it, but I will also scan it in. Okay. And so let's put this into practice now. All right. So difference of squares. This is on 9.3. Now that's a lot of information. Like I say, with factoring, it can get so overwhelming. I really believe that it's more about if you understand the concept and what's reasonable, what it actually means, what you're doing, and how to recognize the problem you have, that's more than half the work with factoring. Okay? Especially with binomials where there's not a lot of math, it's more about the recognition. So the difference of squares, so we're starting with just the squares. We'll do the cubes in a second. So the squares mean you have a perfect squared first term minus a perfect square second term. And if you recognize that, you find your A and you find your B. You unsquare your two terms. And very importantly, notice that this is subtraction. If that is a plus, it is prime. Okay? So you're not just unsquaring your A and your B, but make a note. Oh, that's subtraction, so I can factor this. Then all you have to do, you're done. You've got your A and your B already, so it's A plus B, A minus B. Done. You're factored. Move on. Okay? Don't overcomplicate this. These are conjugates. Difference of squares, factor into conjugates, period.
So, yeah, it is.
Now, the more you recognize perfect squares, the easier your life is, just like knowing your multiplication chart. Okay? Knowing at least your first 15 is very useful. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared. The more you recognize those, the less you have to rely on your calculator and you're more efficient. Okay? Now, if you forget, or for bigger numbers, remember that when I say unsquared, I'm talking about square rooting.
Yes, ma'am.
And that is the symbol right above the x squared button. So if you're not sure, for example, if, say, 625 is a perfect square, then square root it. Second, x squared gives you the square root sign. And let's say I wanted to test 625, I'm not sure. Close my parenthesis. And if you get a non-decimal answer, then yes. Because 25 squared takes you back. There's inverse operation. So the square root will tell you if it's a perfect square or not. But the more you recognize off the bat, the more efficient you are. Just like knowing your multiplication tables. Okay. All right, so your basics. X squared minus 121. Hey, I I think those are both perfect squares. What's my A? What's my B?
X and
Yeah. And make sure,
11.
subtraction, right? So knowing that, hey, you identified difference of squares. You unsquared your two terms.
Okay.
And so my factored form is,
X plus 11 and X minus 11.
yeah. Boom, done. Move on. Huh, that's a very big exponent. That's a 2, y squared. Now, this is a difference, right? And is that a perfect square?
Yes.
And is that a perfect square?
Yeah.
Don't do this. Don't write y squared minus 36.
It'll be Y something. It has to get the right Y in parentheses.
Mm-hmm.
Yeah. Oh, okay.
If you were given this problem, this would be correct. But is that what you were given? No. This 36 is positive, right? If you turn it around, you made it negative. And that's a negative y squared, but you made it positive if you turn it around. This is the correct answer if that's what you were given, but it is the wrong answer for this. Your eye really wants that variable first. Okay? But, or your brain does, yeah, but ignore it. What's your A? Mm-hmm. And what's your B?
Negative
Y.
Y.
Y. Yeah, when you're doing your A and your B, you're ignoring your sign. The formula, the conjugates, takes care of the plus and the negative. So your A and your B are just 36 and y squared, or x squared and 121. Because you can't unsquare a negative, okay? You just want to make sure there is a negative there, a subtraction there, because then you know you have a difference of squares. And do it in that order. This is the order you were given, use it. Your brain really wants that variable to be first. Because the order matters with subtraction. If you would actually rewrite this, you would have to rewrite it as negative y squared plus 36. And can you factor that?
No, because it's the
Yeah.
negative.
Yeah. 1, a negative is not a perfect square. And 2, that's a plus in the middle. It's a sum. Okay? So don't do that either. Okay? Just do it in the order you're given. Your A is 6. And your B is y. 6 plus y, 6 minus y. (49) x squared minus 1. I'm going to give you, actually, I'm going to go to a second page here because I want to give a few for us to work ahead on. Okay, so 49x squared minus 1.
Okay.
4x squared plus 25. 81x squared minus 4y squared. 25m squared minus 100.
That -1, you have to bring it somewhere now, shouldn't you? I'll wait till you go up with that.
I'm sorry?
Doesn't it? I was just wondering, so. Oh, okay.
Yeah. 1 is a perfect everything. A perfect square, perfect cube. Yeah. When you unsquare, uncube, or anything, 1, it just is 1, because 1 times itself, however many times, still equals 1. Yeah.
I have a quick question.
Yes.
On the second one,
Mm-hmm.
would be 2x.
Yeah, if you have to unsquare everything, right? So
Yeah.
2x, right? Mm-hmm. And then 5, yeah.
And then 2x.
So it'd be 2x plus 5, 2x minus 5?
No, I'm not.
No, it's
Prime, yeah. Yeah, that's a perfect square. And that's a perfect square, so your eye immediately wants to go, perfect squares. But you also have to check the sign, because sum of squares are prime. There's no, if you write conjugates, if you actually then check your work and multiply them back, you'll see that you won't get this. Okay? Conjugates, if you wrote the answer as conjugates, when you multiply them back, you'll get 4x squared minus 25. But that's not what you were given. These both have variables on that one. That's fine, because everything's squared. Both coefficients and both variables are perfect squares. What about that last one? 25 and 100 are perfect squares, right? Huh? I wrote the minus first, but it doesn't matter. Remember, the order doesn't matter. One's plus, one's minus. So, if you wrote this, well, you'd be wrong. Why? GCF, exactly. And maybe if you don't recognize it first, when you get to the end, notice 5 and 10. Hopefully your brain will go, wait a second, 5 and 10 have a GCF. Now you can go ahead and take it out now, but you have to take it out of here, and then multiply it together, and you can fix it, but why make your life more difficult? Now what's tricky about this is 25 and 100 are perfect squares. But you don't ask yourself anything else until you ask yourself, what do? GCF. Because when you take out a GCF, everything else can change. You may not, when you take out a GCF, you might not be left with perfect squares. Okay. So this is not right because it's not wrong, but it's not finished. Okay? And you can create a lot of chaos trying to take the GCF out now. Always take it out first. Yeah, these are perfect squares. Doesn't matter. You haven't taken out the GCF first.
Well,
That's just
wouldn't you just bring down like 2? It'd be like m minus 5, and then m plus 2 and m minus 2, right?
Yes, exactly. Yeah. Once we pull out the 25, this is what we're left with. And remember, how do you...
well, you could have
You have to
done it
multiply it, right?
from the finish factor, like I did.
Oh, you pulled out a 5 here?
Yeah.
And a 5 here, and
Yeah.
5 times... But then you got to also know 5 times 5, 25. It's not that... It's this wouldn't be m plus 2, m minus 2 with a 5 GCF. It'd be
Yeah.
5 out of here and 5 out of here, which is
Yeah.
25.
Yeah.
Yeah. And it's just asking for trouble.
Yeah.
Yes, mathematically it's handleable. But
Yeah, but it's...
yeah, it's why make your life more difficult and why ask for more careless mistakes. Yeah. But remember, how do you know you're done is the end of the mantra. Do we have all linear factors?
Yes.
Is that linear?
Oh, the
Yeah. By GCF, I'm done with my GCF, but my binomial factor still has a square. Now, it may or may not be factorable, but I do have to ask myself. If it's not linear, I have to ask myself if I'm done. Perfect square, and subtraction. So now my A is m and my B is 2. So my final answer is the GCF of 25, and then my conjugates, m plus 2, m minus 2. Yeah.
What if instead of you, like how you did it,
Mm-hmm.
or it's the same. Never mind.
Yeah. Okay. If you have a slightly different strategy or way of organizing your work to get there.
I just did, as in like just m squared minus, what is it, 4?
Uh-huh.
And then you just do it from there.
Yeah. Like not writing down the A's and the B's?
Yeah.
Yeah. I want you to get past having to do this.
Yeah, can you show us that strategy? 'Cause
Yeah.
my brain works
Okay.
with it, so.
Okay. Yeah, I mean, the next ones I do, I'm not going to write this down here. And you keep writing it down as long as you need to or want to. Okay, you find the way to mark up your paper and use your strategies to work for you. So this is what I'm doing, but the more you can do difference of squares mentally, the better, because this is a kind of factoring that does not go away. It comes up again and again and again. Okay? So, negative n, let me put a different piece of paper here to finish this up. Okay. So, negative n squared plus 16. 128 x cubed minus 338x. Yeah, right? X squared minus 4 over 225.
You're just going to divide them though, right, basically?
When you have to unsquare things. So if you've got a fraction, remember a fraction? If you have a fraction squared, that means a fraction times itself, right? So unsquaring means finding the fraction that would times itself would equal this. And remember, fraction multiplication, you're just multiplying straight across the top and straight across the bottom. So you're just trying to find what two numbers multiply to make 4,
2 times 2.
right? And what squared numbers multiply to make 225. So you're just unsquaring the numerator and the denominator. Huh? So don't be intimidated by the fraction. You're just unsquaring two things. It still stays a fraction. But this is only a perfect square if the numerator and the denominator are both perfect squares. Now, I do need to, I hate rushing at the end, I do want to have time to demonstrate the cubes. So I'm going to move through these pretty quickly just to point out some alternate issues you're going to see. All of these type of problems here are represented in the homework. Okay? So these are just some other issues you might see. You might see that sum, for example, go up, can't do it. But look at your square term in front.
Negative, you can do it.
You have one of two choices.
Okay.
You can do this or you can do this.
Okay.
You can either factor out a -1, because all that does is flip signs. So that leads to -1 times positive n squared minus 16. No problem, right? Now you have a difference of squares. And that factors into a GCF of -1 and then n plus 4, n minus 4. So I just did that mental A and B, unsquared and unsquared. N plus 4, n minus 4. Oh, sorry. There you go. Okay. So if you've got this negative first term but a positive in the middle, so instead of positive negative, it's negative positive, you can factor out a -1 to flip the signs, and then you have a GCF of -1 and you got your conjugates, or you can just turn it around, 16 minus n squared. The 16 is still positive, the n squared is still negative, but then you write it as 4 plus n for minus n. See, the order changes. If you pull out the -1, then that n is first, and it's your A. If you don't pull out the -1, you just flip them around, then your A is the 16 and 4, and your B is the n.
I like the second one.
Yeah, your choice. They get to this. These have the same value. These are the same value. If you multiply them out, they're the same. They're equivalent answers. Math Lab will accept either one, and so will I. Yeah. All right. So here, you've got to be aware. What's the first thing you do? GCF. Yeah. And we got by this one both a numerical and a variable GCF. Okay. So that gives us 2x on the outside and then 64x squared minus 1, I believe it was 169, yeah. Okay. Okay. Because that 128 is not a perfect square. X cubed certainly is not a perfect square. Oh, maybe this is a difference of cubes. Nope, not with an x there. That's not a perfect cube, and that certainly isn't. These are not perfect squares or cubes. Until you take out a GCF, you would think you're done. This is a case where if you don't take out the GCF, there's no fixing it. There's just no moving forward. Okay. Now, perfect square, perfect square, perfect square, difference. So you put out GCF. Hey, this isn't linear. Can I keep moving? Yes, I can. 2x. And that would be 8x minus, or plus, either one, 13, and 8x minus 13. Okay? Because unsquared, this is 13, unsquared, that's 8. Here, no GCF. Perfect squares, because 4 is a perfect square, and so is 225, and it's a minus. X plus 2 over 15. You unsquare the top and the bottom. Don't stress about fractions. And then x minus 2/15.